Hello everyone, this is Jangul Aslam. I'm one of the students taking the CSCIE-63 Big Data Analytics course in Harvard Extension School. This is spring 2014. This is my final project presentation for which the concentration is D3 data visualization, and the topic I chose is, or the problem I'm trying to solve here is visualizing phone call records using D3.js. So let's go through the slides and see what I've done. I'll basically talk about why visualization is needed. Uh, I'll talk about what D3 and related technologies provide for visualization. I'll talk about my project topic and its description. Then I'll give you some details along with the demo, and then we'll conclude. So why visualization? Uh, if you look at our data, our information, any kind of information, is mostly in some text form, like in logs, CSV file, XML, JSON data, or something, and and it is very hard for humans to look at these text and analyze it. It's a very tough job, boring job too. Here is an example. I'm looking at a phone record, and on which the first line is the column names, and the second line and beyond are the data, for each columns. And it's kind of not easier looking at the data to find out that to come up with a pattern, and to find out what has been happening on this in this data. So as we have the saying that a picture tells 1,000 words, we need visualization. We need visualization to for this data, so that we can make something meaningful out of it, and it become an easier job for humans to analyze it. So here is an example, and this is an output from my project. But here is some chart for the data we saw, for the month of January. So let's talk about D3 and related technologies. So D3 is stands for data driven documents. It's basically a JavaScript library for the front end developers uh, who needs to visualize any data, and it provides really nice images, as you can see at the bottom. And the visualization is tied to a data. What does it use? It's based on SVG, which stands for scalable vector graphics, which allows us to render better visualizations at any resolutions within a browser. Along with SVG, it needs HTML and CSS and JavaScript, and basically the visualization is rendered within a browser. So what does D3 provides? D3 has many things, like you can draw basic objects, rectangles, lines, circles, using it. And D3 has a concept of scales. It has axis feature, and then it has transitions, it has user interactions, and a lot more. Here is the open source location for the D3 API reference. Now let's talk about my project topic. So the topic, as I said before, is visualizing phone call records using D3. And in below lines, I've been talking about what the problem is, and how this project helps to solve that problem. And let's talk about the project details. I have downloaded my cell phone records from my AT&T wireless account, and I have modified, which is basically in CSV format, and I have modified some personal phone numbers, so that some bogus numbers, for privacy reasons, I guess. And basically I have learned the D3 JS programming, And here is the directory structure of my project. Basically everything is in py http server folder, where I have the index.html as the my main HTML file. I have styles.css for styling. I have main.js, where most of the JavaScript related to D3 is residing. And then I have a data folder which has the sample.csv, which is basically 3 months of CSV phone record data. And then D3 is like a third-party library, JavaScript library. So I have a vendors folder where I have downloaded the minified versions of D3, Java Query, and required JS for implementing this project. And so that's what I just spoke about. So let's look at this screen, and where I can show you how the visualization is, how the output of visualization is. So if you look at here, this is a screenshot from Chrome browser, and basically there is a chart with rectangles, and there is an x-axis which is the days in that data, starting 12/29, which is December 29, 2013 to April 6, 2014. And then the y-axis is the hours of a day, and we have rectangles, various rectangles for each individual data. And I have given the color. The color blue stands for the I think it's the incoming call, and the purple is for outgoing call, and the height of the rectangle, it tells the call duration, so that it aligns with the what time the call was started and what time the call was ended in the graph. And then I have also given a select box on the top, where you can select the data range. So you can say visualize all data or visualize monthly data. And then on the chart itself, I have given mouse interactions. So when you move your mouse on these rectangles, a tooltip will be shown, which will give details about that particular data. So it will tell outgoing data or incoming data, incoming call or outgoing call, and it will give other information about which day, time, date the call was made, what number it was called. For outgoing data, AT&T data set has the location where I was calling to, and the duration. So this is how I'm visualizing the phone record, which is a lot meaningful. Let's go and have a demo, and then we can talk about the implementation detail. So I'm gonna open a browser, navigate to localhost 5000, which is where my HTTP server is gonna run. So I'm gonna start my HTTP server, which is a Python simple HTTP server. I've started that, and let's visualize the data. So as you see, our graph is rendered, and in the way I have been talking. So let's see. So we have the x-axis showing the days in the data, and y-axis showing daily hours, starting from 00 to 24. I have a select box which I can select for the data range, and then I have various rectangles for each individual call record. So what I'm gonna do here is I'm gonna move my mouse to a particular call, suppose this one, and now a tooltip is being shown which says that it is an incoming call, and it was made it happened on Saturday, February 1st 2014 at 8:28 p.m. and the call call came from the number 444-555-666. This is the bogus number I replaced, and the duration was 50 minutes. And similarly, I can go to look at an outgoing call, and if you see here the big picture, that I can see that okay, I have been like more on an outgoing call. I've been doing outgoing call more because the purple color is more versus the blue color, which is less. And I can see what hours I've been mostly active. If you look at the pattern, it's mostly from 7 o'clock in the morning to 8 o'clock in the night. All the other time I'm sleeping. And I'm going to select a different data range. So I'm going to select January, and the graph re-renders itself. So if you it is more a zoomed in view now, where the rectangles are a little bit bigger, and so that user can easily interact with them. And here if you see oh, I have been getting them in the morning, like at 1 o'clock, and like early morning or late night, and making calls, and the call was an outgoing call. And why? Because I traveled to California, so I was 3 hours behind, and silly AT&T guys, they don't the data is not like UTC based, but I can see a lot more visualization here, and it looks more prettier now, I guess, because this is a visualization. I can see the whole picture, and I can interact with it, and looking at the picture, I can see whether I have been doing ongoing calls and incoming calls, and how long the duration was. So this concludes my demo. So let's go back to the presentation itself and talk a little bit more about how it is implemented. So I'll go back here. So let's see, so if and we have the code, which I'll probably put in the presentation as one of the links. But the thing is, basically I use D3 to do the visualization. First, I define an area where my visualization will happen. It's of width 800 by 600, and I will so that will be my area. I will do a reading of the CSV file using the D3.csv function, which is gonna return me data, which is a JavaScript array for all the data being read, and if the error happens, then the error will be made. Then I do some processing to find out within my data which months the data is for. So I basically loop around to find out what months the data is about. If the data is really huge, I think we can probably use the big data programming to find out those months. And but here right now it's sequential search. And then basically in D3 we have input domain, which are the values in the data, and then we have an output range, which is the screen, the area on the screen where the data will be scaled. So the D3 has a concept of scales. So basically we will define scales, two scales, one for x-axis and the x horizontal scale, and one for vertical scale. So basically these calls, as you see, these are defining those scale functions, where in the x scale you give what is the minimum date in the data, what is the maximum date, some padding to adjust the screen thing, and y scale is basically number of hours within. So and basically so this scale, x scale, y scale are basically function, and then if you give a particular data value, it is gonna return you a scaled value, which is how we draw the rectangles. Then I have defined the x and y axes and then their location along with the scale. So x-axis is the bottom, y-axis is the left. So now I have done I have rendered these x and y axes by these calls. And then at the end, after reading the D3, so it's in the function callback of the data being read from D3, I go and do the drawing of the rectangles, which is height is based on the call duration, and the color is based on whether it's incoming call or outgoing call. At the end, I want to conclude on this project. I want to draw some conclusions here. So what I've seen is I have really liked D3. There are some and here are some pros for it. So it's a JavaScript library with proper balance in between data processing features and graphics features. And like it relies on HTML, CSS to do the styling and all. So I think it's a good balance in between our data processing part and the graphics part, and it makes web developers to write more readable, extendable modular code. It works in all the latest browsers like IE, Safari, Chrome, Firefox. It renders really well because it's based on SVG. It's crispier, sharper, and there is vast amount of tutorial examples available online to jump into D3, to learn into D3 and produce good results. Some cons which I've seen, or which I can think of now of D3, is like since D3 is based on like HTML, the DOM in the browser. This is how browser understands an HTML and draws things. Is based on dots on DOM, document object model. I think that for large data sets, there might be some limitations that the visualization is slower, but I don't know at this time. But I feel that that's what I've read online. And the other is like if someone has to start using D3, they have to learn the whole web development stack related to it. So like HTML, CSS, JS, jQuery maybe, and JSON and things like that, which might be a little challenging or maybe time consuming. But like other than that, like there are fabulous examples available with very better graphics than mine, and like you can take a look. It's a lot interesting. I've learned a lot in this project, and I hope I've given some meaningful information to you guys as part of this presentation. And thanks a lot for watching, and have a nice time.